Hi class, this video is on graphing quadratic functions, so let's get started. Okay, say we have a quadratic function that looks like x minus 3 quantity squared minus 4. Okay, what does a graph of that look like? Well, first let me show you a cool graphing website called, you can see it right here, demos.com calculator, and you get this cool graphing calculator. And let me show you how it works. You can bring this up and say y is equal to, right? You can say y is equal to x, and we get a straight line there. But we can say now y is equal to x squared, and this is basically what a quadratic equation looks like, right? If we put in x is 0, we get y is 0. If we put in x is 1, 1 squared is 1, we get y is 1. If we put in minus 1, we get 1. But if we put in x is equal to 2, 2 squared is 4, so here's x2 and y is 4. And if x is 3, then x squared is 9, so we go up to 9, and that's what a quadratic function looks like. And you can see them all. If we add now, say 4 to that, it just shifts the whole graph up 4. And then finally, if we do something like this, okay, that didn't affect it, right? It's still x squared. But we can say x minus 3 quantity squared, and that just shifts it over here. This bottom point is called the vertex. And then we can get the intercepts, the y-intercept, and sometimes this might have an x-intercept if I say minus 4. Then we have x-intercepts as well, right? And so we're going to look at those and see how those are graphed. So let's go back to this one. In fact, we might have just had that one there. Let's go back to that. Okay, it is. That's what the graph looks like. All right, but we're going to graph it. We're gonna go through the process of seeing how this graph is if we don't have this graphing calculator with us. So let's do it. Okay, first of all, we want to find out where the vertex is. Okay, and that's the lowest point. Where is the smallest? Well, it's when this thing is 0. So the vertex is basically the low point. Okay, and it could be the high point too if the graph looks like this, but since this one's going up like this, it gets positive when x gets large. It's the low point. And when is the smallest? Well, when x minus 3 is equal to 0, and that happens when x is equal to 3. Right? So when is this 0? Right? That's the x part of the vertex. Now any point has a point, comma x comma y, so we need y in there too. But we throw 3 into that, and if we throw into that, this is 0. 0 squared is 0, and y is just equal to minus 4. So the vertex is just equal to 3 comma minus 4, and that's a low point. Now we could use x and y intercepts, right? The x-intercept right, is where the graph intersects the x-axis, right? The x-axis here. And the y-axis, y is equal to 0 there. So for an x-intercept, y is equal to 0. So if we plug in 0 to this equation, we get 0 is equal to x minus 3 quantity squared minus 4. If we bring the 4 over there, we have 4 is equal to x minus 3 squared. Take the square root. X minus 3 is equal to plus or minus 2. And so then x is equal to 3. Add the 3 over, plus or minus 2. So we have x-intercepts of 3 plus 2 of 5, or x is equal to 3 minus 2, which is 1. All right. And so if we have a graph here, we have the x-intercept at 1, and say at 5 here, we have the low point, or the vertex, down here at 3, right in the middle there's 3, and minus 4, say, is down here. And then we can get a y-axis, or the y-intercept. The y-intercept, right? And that's where x is equal to 0. Right, on the y-axis, x is 0. So if we plug in 0 here for x, y is then equal to minus 3 quantity squared minus 4. Minus 3 squared is 9. 9 minus 4, y is equal to 5. So for the y-intercept, we have 0, 5. All right, so the y-intercept, we got this for the x-intercept right here. And this is really like 5, 0 for y, and 1, 0 for y. So those 2 points. And then if we go up to y is equal to 5, say right about here, that's the y. That is the y-intercept. It looks like that graph isn't great. Let's draw the graph on a nicer thing. Okay, so let's graph this guy. So we take this graph, and our vertex is at 3 minus 4. So right there's the vertex, and 1 intercept, or we can just go with the y-intercept. We plug in 0 for x, we get y is equal to 5. So there's the y-intercept. Good enough. 2 points for this graph. And here's our graph, which looks exactly like our graph here. Okay. Let's do a second example. Let's take y is equal to x plus 2 quantity squared plus 3 this time. So the vertex, again, this graph goes up like this because it's positive here. And the vertex would be where this is 0. So you plug in minus 2 for x, that makes that 0. And we get this guy out here. 3, there's our vertex. Now the y-intercept, okay, we let x be equal to 0 on the y-axis. X is 0. And if x is 0, so that's 4 plus is 7. That's enough to graph it with our tool. But the x-intercepts, y-intercept x is equal to 0, right? And this one, y is equal to 0. The x-intercept, if we let y be equal to 0, 0 is equal to x plus 2 quantity squared plus 3. Bring that over, minus 3 is equal to x plus 2 quantity squared. We have no y-intercepts, no real y-intercepts, right? You can't take a square root of minus 3. So we'll use these two to graph it. Let's bring up our homework graphing thing. We'll clear this. And so we graph this. So the intercept is at minus 2, 3. So minus 2 over here and 3 up here. And then the y-intercept, when y is equal to 0, we get 7. So we'll bring this up to 7. And there's our graph. And if we want to look at our cool DMOS graphing calculator, right, we just had y. We can just make this a plus 2. So it just shifts it over to the left. So there's the new intercept, but then we have to make this a plus 3. There it is without it. So now we bring it up 3. And there it is. Okay. So there's our intercept at at 7. And there's our vertex at minus 2, 3. Okay. Let's do a third one, but this time we'll let it go the opposite direction. We'll let it go down. So we'll like 5 minus, say, x minus 2 quantity squared, or that can be written as negative x minus 2 quantity squared plus 5, either way. And so this one's going to go down because as x gets large, this becomes all negative. So let's get the vertex. In this case, it's the high point right here. All right, well, that's going to be where this is 0, right? That's going to be the least negative. And that's when x is equal to 2. And y is going to be 5. So the vertex is pretty easy when it's in this form. The y-intercept, okay, that's always where x is equal to 0 when it intersects the y-axis, is going to be equal to, well, x is equal to 0. So we have minus 2 squared, which is 4. 5 minus 4 is 1. So 0, 1. That's enough to graph it. Do we have x-intercepts? X-intercepts. Of course, that's when y is equal to 0, where it intersects the x-axis. So if that's 0, we can bring that over. We have x minus 2 quantity squared is equal to 5. We can take the square root. And so we have x minus 2 is equal to plus or minus square root of 5. And our two intercepts is x is equal to 2. Bring that 2 over. 2 plus or minus square root of 5. One's positive, one's negative, because square root of 5 is slightly greater than 2, a bit greater than 2. Okay, well, let's just use the vertex and the y-intercept to graph it. So let's go back to our cool homework thingy. So let's clear this and let's graph it. Okay, so let's take this, and our vertex is at 2, 5, right? So we'll go 2 for x and 5 for y. And then our y-intercept, when x is equal to 0, we're at 1. Okay, that's enough. All right, so there's our graph. Goes down just like that. Okay, let's do one more example. Okay, let's say we have y is equal to something like this, say x squared minus 4x plus 3. Now, if we put it into our graphing, our Desmos thing, right, it can graph it real nice. We're at x squared minus 4x plus 3. Then we get a nice graph there, right? But if we didn't have that, how do we graph it, right? On the homework or on the test, how do we do this? Well, basically, we complete the square. We take these guys, right? X squared minus 4x. What do I need to complete the square? Well, we take half of the 4. Minus 4 is minus 2. Square that is 4. So we really need a plus 4 here. So if we add 1 and subtract 1, right? We don't want to just add something to it. But if we add 1, subtract 1, that doesn't change it. We have a plus 4 here. So y is equal to x squared minus 4x plus 4 minus 1. Now this is a perfect square. So y is equal to x minus 2 quantity squared minus 1. And we know how to handle that. So let's just graph it real quick. is when that's 0, so we got 2, and when that is 2, we got y is equal to minus 1. This point was not the, erase this. That's our vertex. Okay, but for the y-intercept, we let x be equal to 0. So for the y-intercept, we have the point 0. If x is 0, we got minus 2 squared, which is 4. Minus 1 is 3. So there's our second point. Vertex 2, 2 minus 1. So let's graph that. Let's clear that. And we have our vertex at 2 minus 1. So at 2 minus 1 is our vertex. There's 2 minus 1. And the y-intercept is 0, 3. Right, so we have the point 0, 3, and there's our graph, just like we see it on this guy right here. Okay, well, I hope this video was helpful to you and helped you learn this material.